Welcome to the distance learning packet for IM2. This is week 6. This is the second page. Here I'm going to cover whole number solutions, understanding why the equation must be set equal to 0, what happens when you get repeated answers, and a couple things for you to remember. First of all, we're going to go over whole number solutions. This is a good video to watch because I'm going to go over all the steps. Here you might have a problem like x squared plus 2x minus 15 equals to 0. And here they ask you to solve. It doesn't matter what you do. You have to get it to something like x something parentheses x something parentheses. It has to happen by a method of factoring. Once you solve it, let's say this, then you're gonna have like x something parentheses, you're gonna set that equal to 0, then figure that out, then you're gonna have x something parentheses equal to 0. Once you set equal to 0, this is the part where you solve, right? Because you're going to solve by getting x alone. But before you do that, you have to factor. Okay? You have to factor. So the method of factoring here is going to determine on if a is equal to 1 or not. So let's do that. A is my first number. What's that number in front? 1. Perfect. Okay. We could try to use here a very easy one. So diamond method probably, because a is equal to 1. B is blue. B is going to be equal to 2. Perfect. And C is equal to negative 15. Oh, that's easy. Don't even quadratic this. If someone tells you to use quadratic, don't listen to them, because look, a equals to 1. Perfect. All right. Just set up your diamond method. 1 times negative 15 is negative 15. And the bottom one is your blue, which is 2. Now you want to look at what multiplies to make 15. So that's going to be 1 times 15. Ignore the negative, okay? And 2 times, nope, 3 times 5 gets you 15. Okay? Now you want to add them. 1 plus 15, can that get you to 2? No. 3 plus 5, can that get you to? Yes. If this was negative 3 plus 5, does that get you to 2? Perfect. Negative 3 times 5, does that get you negative 15? Perfect. So your factors here are negative 3 and 5. So your answer here is x minus 3 and x plus 5. Are you done? No, 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 no. Remember, you have to set it equal to 0. Do you see the equal to 0? Equal to 0 part. This is where I tell you there are two answers. So you have your x minus 3 equal to 0. How do you do that? X plus 3, x plus 3. Okay, you see how you get x alone here? You're done. But remember, this is for the first one. Now you want to do the second one. X plus 5 is equal to 0. Solve for it. So you minus 5, you get x equals to negative 5. Now you're done. So you would say this would be one of your answers and this would be one of your answers. Alright, this is an easy way to do it. Again, diamond method if a equals to 1. Now next, I'm going to show you something when it looks different. This might look something like 2x squared minus 3x equals to negative 3, and they ask you to solve. Do you see how this is to the other side? Bring it over to the other side so it equals to 0. That's what we mean, equal to 0. So you have 2x squared minus 10x plus 3 equals to 0. Perfect. Now let's look at our factors, or our a, b, and c. A is equal to 2, b equals to negative 10, and c equals to 3. Is a equal to 1? No. So here you're gonna end up having to use your quadratic. Good. So again, start by writing down the quadratic equation. Quadratic equation: x is equal to minus b plus or minus the square root of b squared minus 4ac. You're going to divide that by 2a. Now you're just going to start plugging it in. So the next step, I'm going to bring it up here, okay? Because I need more room. X is equal to negative, b is negative 10 plus or minus the square root. Where's b squared? B, so negative 10 squared minus 4. A is 2 and c is 3. Close the square root. Close the square root. And you're all going to divide that by 2a, and a is 2. X is going to be equal to, I'm going to do the math really quick here. This becomes 100 minus 24 over 4. Then this becomes x is equal to 10 plus or minus the square root of 76. Oh yeah, that's ugly. Over 4. So there's no way to deal with this. Okay, there's no way to deal with this. Notice this, ugly. Okay, so you stop here. Yes, you can leave your answer like this if you cannot simplify the radical. That's it. Okay, next I'm gonna go over what happens when you get a repeating answer. Okay, I'm not gonna go over the problem in complete detail because it's boring, but for those who want to see it, go ahead. If not, you should just skip to where I'm gonna finish the problem. So you're gonna see something like this, and they're gonna tell you to solve. All right, good. Oh, this is easy. Just use diamond method. Why do you don't even need a factor here? Look, a equals to 1. No, that's a equals to 1. B is equal to negative 10, and C equals to 25. All right, very easy to factor. Diamond method. A equals to 1. What goes on top? A times B, which is 25. Bottom, negative 10. What multiplies to make 25? 1 times 25 equals to 25, and 5 times 5 equals to 25. What adds up to 10? 1 plus 25 does not equal to 10. You want negative 10, remember. 5 plus 5, does that get you to your 10? Yep. Even if it's negative, yep. Negative 5 plus negative 5 equals to negative 10. Negative 5 times negative 5 equals to 25. So your answers here are negative 5 and negative 5. You would write it. You would get x minus 5, x minus 5. Notice that these are the same. Okay, remember, set it equal to 0. So it's x minus 5 equals to 0. X equals to 5, because you're going to add. Same thing here. X minus 5 equals to 0. You add 5. X equals to 5. Notice, right? These are repeating roots. All right. This means it looks something like this. Remember when we graphed it? And it could be something like this, right? It's a parabola right here. Looks something like this. And I asked you, how many roots does this have? And a lot of you said, oh, this had 1 root. Correct. It has 1 unique root. Okay? At x equals to 5. But remember, there has to be 2 roots for a quadratic, right? X squared, there has to be 2 roots. But there's a unique root of 5. That just happens twice. Good? So that's what it means. Right? A couple of things for you to remember. All right, let's say you have a problem like this. let's say 5x squared minus 10x plus, let's see, 15? No, 25. Let's see, 257? Yeah. It's not going to factor out pretty. Okay, here, notice that you can put a equals to 5. B is equal to 10. And I think your C value here is 7. Is this correct? Wrong. This has to, here you forgot the negative. Alright, you forgot the negative. Because look, you have to look at the whole number. Okay? Very careful. When you substitute, make sure you substitute in the parentheses. So x is equal to negative b plus or minus b squared minus 4ac all over 2a. You see a? No. Do you see b? Do you see here is negative? You don't want to just write negative 10. You want to make sure each time you make your substitution, you put in the parentheses. Good? Lastly, let's say you finish this. This is the first mistake. This is a common mistake. Forgetting this. Common mistake number 2, the substitution. 3. Okay. Let's say you have this. Let's 5x plus 6. Right? You finish it to be x plus 2 and x plus 3. Are you done? No. This gets you in something called factor form. Alright? Good? You have to set it equal to 0. Set equal to 0 to get your solution. Your solution, or also call your root, because you can't really graph this, right? So you would say x plus 2 equals to 0, minus 2, x equals to negative 2. Here you have x plus 3 equals to 0, minus 3, x equals to negative 3. Because when you graph it, remember what the solution and what the roots are. Okay, it's the intersection. So the graph should look something like at negative 2. So this is at negative 2 and this is at negative 3. Right? So when you draw the parabola, it looks something like this. Okay? Notice here. Notice this is when x equals to 0, right? This is what they mean here, setting it equal to 0. That's what it means, because that is when y equals to 0, right? Because this is the what? Y-intercept, okay? This is when y equals to 0. That's the reason why you set it equal to 0. All right? So, there you go. I taught you what happens when it's a whole number solution. That means factoring is easy. What happens when it's not a whole number solution, where it's ugly, and you have to understand you have to set it equal to 0. Here I showed you what repeating roots look like. Okay, there's one unique root, but they're repeating. And this are just common mistakes. Make sure you find the right A, B, and C value. Make sure you can substitute it using a parentheses and set it equal to 0 so you could find the root and the solution. Alright, but there you go. Those are all your notes for week 6.